Welcome to educator.com. This lesson is going to be about dividing integers. In this lesson, we're going to learn about dividing integers. There are a lot of applications. For example, you would divide integers when you want to find the rate of change, or when meteorologists make predictions about the weather. Or you could even use dividing integers to create a budget. The vocabulary for this lesson is quotient. Quotient is the solution to a division problem. So for example, if you had 9 divided by 3 equals 3, this answer here would be called your quotient. The quotient of two integers with the same sign is positive. You're going to notice that the rules for dividing integers are the same as the rules for multiplying integers. So when you divide two numbers with the same sign, your answer is positive. So for example, let's look at an arithmetic problem. positive 12 divided by a positive 4 will give you an answer of a positive 3. So since the signs are the same, they're both positive for the 12 and the 4, your answer is also positive. If you have negative 12 divided by negative 4, your answer is going to be a positive 3. So once again, we're dividing two numbers with the same sign and your answer is positive. Let's look at the algebraic representation. Positive A divided by positive B equals a positive A over B. Or negative A divided by negative B equals a positive A over B. So, like the rules for multiplying integers, whenever you're dividing by two integers with the same sign, your answer will be positive. Rules for dividing integers continued. The quotient of two integers with different signs will be negative. So let's look at the arithmetic example. If I have negative 12 divided by a positive 4, so here my two integers have different signs, my answer is going to be negative 3. Or if we reverse it and we have a positive 12 divided by a negative 4, my answer is still going to be negative 3. Let's look at the algebraic representation. Negative A divided by a positive B will give me negative A over B. Or a positive A divided by a negative B will give me negative A over B again. So when you're dividing two integers with different signs, your answer is going to always be negative. Remember that in fractions, the negative A over B is the same as A over negative B, which is the same as negative A over B, as long as there's only one negative sign. Let's try some examples of dividing integers. Make sure to always watch the signs. 14 divided by 7 equals 2. So here we're dividing by two positive numbers, so my answer is positive. 45 divided by negative 9. I'm dividing integers with opposite signs, so my answer is going to be negative. 45 divided by 9 is negative 5. Once again, let's pay careful attention to the signs. A negative divided by a negative is a positive. So now I can just worry about the 105 divided by 15, which is, in this case, if you're dividing and you're not sure how many times 15 will go into 105, you can always do a guess and check. So 15 is close to 20 and 105 is close to 100. So it would be around 5 times. Let's take a guess of 5. So here we see it's too small. So now we know on our next guess we're going to multiply it by a higher number. Skip up to 7. Oops, erase that. And there's our answer. So negative divided by negative is a positive, and 105 divided by 15 is 7. Remember not to take a guess, because it only takes a couple of extra seconds to come over and try the actual multiplication problem. Next, a negative divided by a positive is a negative, and 42 divided by 6 is 7. Let's try some examples of using average rate of change, using dividing integers to find average rate of change. Remember that you need to use the correct integer to represent the situation. So for example, a positive integer generally represents an increase or a rise, whereas a negative integer will represent a decrease or moving downwards. Say a person spends $360 in 6 days. So if you're spending money, your money is going downwards in your bank account. The amount is going downwards. So let's call it negative 360 because we're spending. We're not gaining it. And I'm going to divide by 6 days. So a negative divided by a positive is negative. 36 divided by 6 is 6 with the 0 tacked on. So negative 60. And make sure that you remember to think about what they're saying. So what we're saying here is the bank account is decreasing $60 per day. Next, let's look at this example. Runs 1,000 feet in 4 minutes. So if you're running, you're moving forwards. So we're going to call this a positive 1,000. And we're going to divide by 4 minutes to find out how much this person can run in each minute. So I'm going to set up my division problem. 4 will go into 10 twice, leaving me 20. It'll go in 5 times perfectly. And then lastly, don't forget the 0 at the end. You need to fill in a 0. Make sure you're not writing 25, but rather 250. So 250. Now let's go back and make sure that we know what type of units we're talking about. It's 1,000 feet in 4 minutes. So this person is advancing, moving forwards 250 feet in 1 minute. So here are some average rates of change. Let's look at an average rate of change in a word problem. Joe's baseball card collection was worth $900. Over the last 4 years, the collection decreased $320 in value. What integer represents the average decrease in value each year? So let's start off by creating integers that represent the situation. So Joe's baseball card is worth $900. That's a positive amount. That's how much he has, $900 worth of baseball cards. Over the last 4 years, the collection decreased $320 in value. A decrease in value means we're going downward, so it's going to be a negative $320. What integer represents the average decrease in value each year? So actually, this information here was not necessary to know. It's not asking you how much has the value of the baseball card collection gone down. Rather, it's asking you how much the value went down each year. So let's focus on the negative 320 because that's the value, that's how much the baseball card went down in value. And we're looking at over a period of 4 years. So let's take 320 and divide it by 4 years to find out how much it went down each year. A negative divided by a positive is going to be a negative. And 4 doesn't go into 3, but it'll go into 32, 8 times exactly. And we're left with 0. Remember that it's not $8, but rather it's been going down $80. So each year, the decrease in value has been $80. Here's another average rate of change word problem. Susie purchased stock at $25 per share. After a week, the stock is worth $39 per share. What integer represents the average increase in stock value each day? All right, so right now Susie's stock is $25. And then a week later, her stock moves up in value and becomes $39. Let's find out how much her stock has gone up. So I'm going to subtract the original value from her present value. 9 minus 5 is 4. 3 minus 2 is 1. So her stock has gone up $14. And this was over a period of a week. A week has 7 days, and that's what we're looking at, days. So I'm going to take $14 and divide by 7 to find out how much it went up in value each day. 7 goes into 14 2 times. So it's a positive 2 because it's been an increase in value, and each day it went up $2 until it reached $39. So the integer that represents the average increase in stock value each day is 2, a positive 2. If it wasn't asking for an integer and it was just asking for the average increase, you could say $2. But an integer doesn't need the symbol. Here's another average rate of change in word problems. A subway starts out at 0 miles per hour. After 20 miles, the train is traveling 80 miles per hour. What integer represents the average increase in speed per mile? So the subway is at a stop in the beginning, and then it starts gaining speed. And after 20 miles, it's now traveling at 80 miles per hour. So we want to find out for each mile. Right now we know for 20 miles it goes up to 80 miles, but we want to know for just 1 mile. So let's take the 80 and divide by 20. Goes in perfectly 4 times. So that means that the average increase in speed per mile was 4 miles every mile. So the integer would just be 4. So each mile it increased 4 miles per hour. All right, dividing integers. Just like in multiplying integers, if you have an odd number of negatives, your answer is going to be negative. So for example, an odd number of negatives would be negative 12 divided by negative 3 divided by negative 2. I have an odd number of negatives here because there's 3, and that means that my answer is going to be negative. Let's check it out. 12 divided by 3 is 4. So here at this point, a negative divided by a negative gives me a positive 4. And then a positive divided by a negative will give me a negative. 4 divided by 2 is 2. So when you have an odd number of negatives, your answer is negative. When you have an even number of negatives, your answer is going to be positive. So, for example, if I have 32 divided by 4 divided by 2 divided by 2. I have an even number of negatives, so my answer is going to be positive. Oops, let's put in our even number of negatives here. All right, a negative divided by a negative gives me a positive, so 32, negative 32 divided by negative 4 is a positive 8. Let me bring down everything I haven't used yet. Next, a positive divided by a negative will give me a negative. And then lastly, a negative divided by a negative will give me my positive 2. So notice that when we started out with 4 negatives, an even number of negatives, our answer came out positive. Let's look at the order of operations and the sign of the final answer. I'm going to start out doing this problem by just working through the order of operations, so moving left to right. A negative divided by a negative is going to give me a positive. Sometimes you could put a little positive here to remind you that you've already taken care of the sign. 120 divided by 5. So let's come to this side, do our division problem. 5 will go into 12 2 times, giving us 10, and 5 will go into 20 4 times. So first off, I start off with a positive 24. I'm going to bring down what I haven't used yet, which is dividing by negative 4. Lastly, a positive divided by negative will give me a negative. 24 divided by 4 is 6. So this is called using the order of operations, just moving left to right and performing the operations in the correct order. Let's look at a situation now where I would just look at the signs first and evaluate the signs first. A negative divided by a negative is a positive, and divided by a negative is a negative. So now I'm going to put my negative sign here and then not worry about the signs anymore. I've already evaluated the signs and know that my answer is going to be negative. So now I'm just going to pay attention to the numbers. 144 divided by 12 is 12. And then 12 divided by 4 is 3. And I know my answer is going to be negative. I already figured that out, so my answer will be negative 3. Let's look at an example with substitution. So I have 2d minus c divided by 4 times the sum of d and c. And we're going to be substituting c equals negative 2 and d as 5. Let's go through and rewrite our problem first. Be careful here that we have a double negative. Not only is there a subtraction sign, but the c itself carries with it a negative sign. So I have a double negative here. My d is a 5, and this is going to be plus a negative 2. Second parentheses. Okay, I'm going to work first inside the parentheses. 2 times 5 is 10. And then a negative times a negative becomes a positive 2. Next, I'm going to go here and evaluate a little bit here. These are going to give me a negative. So it's going to be 4 times 5 minus 2. Make sure that you don't do too many steps at once because that might cause you to miss a step. Next we have 10 plus 2, which is 12. Then I'm going to come here. 4. 5 minus 2 is 3. And then lastly, inside our brackets, 4 times 3 is 12. And 12 divided by 12 gives us the answer of 1. Let's look at an example with rate of change. A hiker is descending a mountain. He moves downwards 450 feet in 50 minutes. Find his average rate of change in elevation in feet per minute. So he's moving downwards, so the correct integer would be a negative 450 to represent downward motion in 50 minutes. Negative 450 feet in 50 minutes. And it's asking us to find feet per minute. Per means for 1. So I'm going to do negative 450 divided by 50. A negative divided by positive is a negative. Doesn't go into 45, but it will go into 450. An easy way to think about this is how many times 5 will go into 45. 5 will go into 45 9 times. And then don't forget the 0 tacked on at the end. Oh no, that 5 will go into 45 9 times, and then that's including the 450 with the 0 here. So we're moving downwards at 9 feet per minute. And that would be our rate of change. You could also set this up as a proportion. So you're moving downwards 450 feet every 50 minutes. And as I just said, per minute means for 1 minute. So you could put 1 minute here. And then so you're looking for the change in elevation. And then to solve the proportion, 50 becomes 1 when you divide by 50. And so we would do the same on top, divide by 50 on top. And this problem is just negative 450 divided by 50, which we have done here. And so your E would equal here. Your elevation would equal negative 9 feet per minute. There is a wading pool in John's yard with 40 liters of water in it. After 5 days, 25 liters of water have evaporated. What is the rate of evaporation of the rate of change in liters per day? Or what is the rate of evaporation or the rate of change in liters per day? So it's called rate of evaporation, or another way to say it is the rate of change. So they tell us that there's 40 liters of water in the pool right now, but actually we don't need to know that information. What we're really focusing on is how much the water evaporates each day. And we know that the water evaporates a total of 25 liters. And this is in a time period of 5 days. So it's just a division problem of 25 divided by 5. And that's 5. So it evaporates 5 liters each day. Thank you for watching educator.com.